Thanks, Boo. And thanks very much to yourself and the organisers for having us here at this event, which is fantastic. There's been some excellent talks by some experts. I should caveat by saying I am not an expert, in spite of my attempt at looking scholarly wearing a jumper. But I should explain that, as my wife would say, I'm an enthusiastic amateur when it comes to talking, so hopefully I can do a good enough job of explaining what our vision is in this space. So as you can see, our overarching vision is that colorectal cancer should be a thing of the past. It's a preventable disease, and so it feels achievable from that context. And we'd like to see it consigned to the history books, but clearly that is a huge challenge, and there are a number of facets to that challenge. Hopefully this is working. There we go. So what is the scale of that challenge? As I say, it's multifaceted. So on an obvious level, there's a societal medical challenge, which we'll talk about. There's also data-related challenges within that, and then there's those that you could categorize as clinical. So from a societal perspective, obviously it's a huge disease burden globally. That burden is growing. The deaths from colorectal cancer are set to rise. And in terms of costs, clearly it puts a great strain in terms of resources, and catching the disease early is key really to be more cost efficient, because the increase in cost goes up tenfold if you move from early to late stage detection. And that puts pressure on health systems, and I don't need to talk to the audience about this. There'll be many of you that recognize those pressures and are dealing with those pressures every day. And then from a data perspective, some of this has already been described in an earlier presentation very eloquently, but one of the key things is around data annotations. How do you really benefit from data that is, to steal a phrase that was used earlier on, unstructured data? How do you make that data structured in a way that you can use it? The other thing is that the sector is hugely dynamic. It's an emerging sector. In some senses, we're talking about it like it's just arriving. Clearly, it's already arrived. It's here. It's all around us in terms of the devices that we use, the way we interact with it. And we see that being a very dynamic situation in healthcare. So how do we make sure that we capture, if you like, the right opportunities within such a fast-moving sector? And then also, I'm here talking really about colorectal cancer and specifically about lower GI, but the other challenge around data is how do we really gather enough data in other treatment areas, other anatomies to be useful in other clinical pathologies. And then finally, the clinical challenge, and all of these three things are clearly very much intertwined. So from a quality perspective, your first objective, I suppose, is certainly not to diminish quality, and if you're not improving quality and you're not improving, I suppose, efficiency in the way that you deliver at least the same level of quality, then you're on a non-starter, really. So how do we have a systematic approach to that? And clearly, an objective is from a colorectal cancer perspective, is to minimize false negatives, so reduce the number of adenomas that are missed effectively. And then also, one of the big challenges is, and this is often the case with technology, when you bring new technology in, it's potentially easier to use the technology to address some of the things that are maybe already more manageable, and the more difficult things take time. So in this context, the more difficult pathologies, atypical pathologies, there isn't the richness of data there, the quantity of data there, and maybe the characteristics of those pathologies are quite difficult to deal with. So in this example, things like fat lesions. And then lastly, but critically, how do we make sure that the AI is a sort of holistic tool and is aiding diagnostic holistically in all parts of a treatment process, of a procedure, so supporting with both detection and characterization if we talk about polyps and adenomas. So what does this mean for us in terms of our vision? So if you'll indulge me for a second, before I get on, I suppose, in terms of what our vision is specifically, I wanted to frame it around the context and the things that we see in terms of the environment. So this was also mentioned in an earlier talk around thinking about the past and technologies that we might see as disruptive and that have changed the nature and way we interact with our environment. And I've picked out 3 examples there, computers, phones, and cars. I think there's a few things that we'd reflect on in terms of disruptive technologies. This is not by any means an empirical definition, but disruptive technologies tend to reduce the amount of effort that the user needs to expend in order to achieve a certain task. And or make the process more efficient in some way. And I think that's true of these 3 areas. I think the other thing I'd say about disruptive technologies and progress is we tend to only make sense of the pace retrospectively. And as technology creeps into our life and we use it more and more, our expectations tend to rise. That's why I go blue in the face on a train when I can't get a connection with my mobile phone. I don't pause and think about where we were 30 years ago. I'm just mad that I can't get a constant connection on a speeding train. So my expectations of technology are very high. I think the other piece that's relevant about these areas is that you need a level of context and expertise to use that technology most effectively. So as a very sort of, I suppose, limited adage, but a little analogy, I was coming here this morning, I was using my phone, looking at a map. There's, that's AI within that technology. I saw where the building was. I walked up Albany Street, and then I realized, of course, that you couldn't access the building from that street. So I didn't have enough context. I wasn't bringing enough knowledge of the area to make use of what the data was telling me. And I think that's the key point, is that in order to get the best out of the technology, you want to pair that with a level of expertise. So if you look at computers, if you want to get the most out of a computer, you probably don't actually speak to a programmer. You probably speak to someone who's an expert in the particular application that's being used. Similarly with cars, experts in driving, racing car drivers get the most out of the technology because they're experts. It's not the engineers who build the technology, it's the end user. And then, as everyone knows with phones, if you want to get the most out of a phone, you just need to speak to a teenager. So where does that leave us? So I think one of the key things that we feel, and this is a very local colloquialism, it's an English kind of phrase really, that we don't want to put our eggs in one basket. We recognize that our core competency from where we are today is not in AI. And we, those that know Olympus, historically, we're over 100 years old, but we started really in microscopy and microscopes, and we've moved into endoscopy, and we're a leader in endoscopy, but we understand and we appreciate our limitations in terms of our starting point. So ensuring that we don't put all our eggs in one basket is a really important part of our approach. So what we're really talking about here is a framework in which to integrate, orchestrate and integrate the AI workflow. And what we want to be able to do is be relatively open in terms of the platform, so we can, I suppose, maximize our opportunities to integrate the best of breed solutions. So working with a number of partners who are expertise in the AI field and integrate those platforms into ours. And crucially, as I mentioned before, we want the aid to be a holistic diagnostic tool, so detection and characterization. Now, I'm going to talk a bit about one of those platforms in a second and show you some footage. There are a number of partners we're working with. I don't know if this is still happening. I'm hoping it is, but later on, Mr. Amin Haji was going to talk about EndoBrain from Cybernet, which is one of the partners that we're working with, and that's a fantastic piece of technology that would be great if Amin's here to talk about it. So I didn't want to steal his thunder, so I'm not going to talk about that. I'm going to talk about another platform. Again, this slightly misleading slide on 2 fronts. The future has arrived. Well, we are currently in a position where we don't have a CE marked product. So what I'm going to show you is not available, but it is in use. It's being validated and used, and we hope to make that the CE marking and make it available in the near future. And also, as I mentioned, we're talking about AI in the context of a very specific field. Clearly, AI is being used in a lot of other fields as well already. So let's have a look at the video, and hopefully I can talk you through what's happening. So at the moment, you can see in the bottom left-hand corner, we're in detection mode. So the software is able to, in a dynamic context, to pick out abnormalities and find polyps, and it's just flagging those with those blue boxes, as you can see, pretty intuitive. Now, MBI has been switched on, so that activates the characterization mode. You can see there's a sort of a warning, if you like, that the picture is not stable, so it needs an element of stability in order to classify. So it's using the system to classify whether you're looking at an adenoma or not. So I should say that within the footage, you're only seeing one description. So it's saying adenoma, it's not a binary system, so it will tell you whether it believes it's an adenoma, whether it thinks it's not an adenoma, or if it says nothing, it's not generated a level of confidence to make a prediction on that basis, either because the stability is not there or potentially for other reasons, which I'll go into in a second. So as I said, that's from a company called AI for GI. So how does it work? And the feeling that I have and our approach to this is understanding how the system works and how the system's making decisions is a key part of learning how to use the tool and understanding what information's being put in front of you. So basically, it's using a convolutional neural network produced through deep learning. It was trained with unaltered, knob-magnified real-time footage. So it's unadulterated footage. It's not sort of tailored to be perfect imagery. It gets activated in the characterization mode, as I say, when MBI is switched on, and it uses the MBI International Colorectal Endoscopy Classification, so the NICE classification. So if you look into, there's a paper that you can read, which is by Byrne and al., that actually talks about this technology. So some interesting things from it. So it reaches a level of accuracy of above 94%. And I think one of the interesting points to make here is that if you look at the data from the NICE recommendation on the use of NBI and other technologies to basically do optical diagnosis, it's reaching about the same level of accuracy. So it's reaching the same level as experts. But I think what it has the potential to do, and I think AI has this potential more broadly, in a specific field, is to, if you like, move the Gaussian curve to the right, to raise the general standard and the average and reduce some of the variability. But importantly, within the sample, as you read in the paper, 15% of the samples that we used to train the system, the software was not able to generate enough confidence to make a decision. So ultimately, garbage in, garbage out. So you still need a reasonable level of quality of imagery and footage in order for the system to generate a level of confidence for that decision making. So in summary, our overall vision, as I say, is the sort of broad aim to put colorectal cancer in the history books and leave it there. And in order to achieve it, there's obviously a number of challenges we need to meet very broadly across societal challenges, data-related, clinical challenges. We believe that AI is a tool that can really help with that, but crucially, we believe it is just that. It is a tool that, paired with a level of expertise from the end user, can be really a powerful way to address these challenges more efficiently. Thank you very much.